such a great pleasure and an honor to be here with you. Every time machine, it seems, is better than the last, more exciting than the last. And this time round, I have to say, just the quality of the people that have joined us is incredibly humbling. And if you would allow me a minor deviation from what I was going to say, I am seeing Professor Metcalfe, who's sitting right here, for the first time since he won the Turing Award, which is the Nobel Prize of Computer Science. And I would like to recognize Professor Metcalfe is an unbelievable innovator, the inventor of Ethernet, part of the original crew at Xerox PARC that gave us modern computing. And he just received his award just literally a month ago. And we are also extremely lucky at Spark Cognition that he is a distinguished researcher and an advisor to the company. So with that, let me talk about my main focus for my comments today. In my view, the AI disruption is not only here, but it's taking a very interesting shape. And you might say that this word emergent kind of doesn't fit here, but I'll explain to you how it does. The AI disruption is becoming emergent. It's not becoming obvious, it was not constructed, it is becoming emergent. And again, we'll investigate what that means. First of all, we have to contend within the AI community with the reality of the fact that any great technological aspiration has its naysayers. If you have seen over the last, say, decade, 15 years, the opinions that a lot of people have expressed, whether in the press or perhaps in large companies or in communities, journalists, many of them have said, look, what is this AI business? AI is just statistics, right? That's all AI really is. AI can never outcompete domain experts. I'm a 40-year experienced vibration analyst. Are you telling me that an AI system will come in and debug or identify problems in a turbine that me with my 40 years of experience in vibration analysis will not be able to do? And you take this, it's not to pick on vibration analysts, but you take this in any profession, the effect is about the same. Then, of course, there are others who look at the history of AI maybe in a cursory way and say, well, you know, what's new here? It's been around since the 60s, and didn't it fail then? And didn't it fail again in the 80s? And didn't it fail again, you know, recently? And then finally, to organizations, whether these are governmental, independent, commercial, and you'll say, look, you know, I am a huge organization. I'm like an aircraft carrier, and I'm going in one direction with a lot of momentum. So what is this AI and how is this AI going to disrupt me? I think it's overstated. I think the amount of change that this is going to force me to drive in my organization is not warranted because I just have the heft to get through this transformation with no trouble. Now, of course, I am an unapologetic believer in artificial intelligence, and I think it's the most important thing that will happen during our lifetimes and probably for a long while thereafter. So with that caveat, let me tell you sort of what my view of these things is. When we started Spark Cognition, all of the criticisms that I just shared with you, in fact, I remember some of my earliest customer visits, our dream with Spark Cognition was to apply AI to the physical, to create a marriage between atoms and bits, to imbue physical systems with intelligence. We weren't satisfied just recommending the next Netflix show or optimizing the click rate on an ad. We wanted to bring artificial intelligence to global infrastructure, which is a $100 trillion problem. And unless we improve this global infrastructure by making it safer, by making it easier for people that are less experienced to use, by reducing the carbon footprint of this infrastructure, then we're in a world of hurt because what do? Either bear the consequences or rip and replace $100 trillion worth of stuff. Not doable. So the only answer to infrastructure is going to be artificial intelligence. Add the software that upgrades the hardware and makes it run better. That's the net-net. So Spark Cognition was conceived as the first industrial AI company that was looking to build an OS for global infrastructure, which is a huge vision for a guy and an algorithm and a PowerPoint. But over the years and over the months, that vision took hold, and a group of people, a group of partners emerged that helped us along on this vision. Then with General John Allen, I worked on this idea of the application of AI in the field of battle. And from that, a whole body of work emerged, this idea of hyperwar. And at the heart of that idea was this notion that the observe, orient, decide, act loop, which is what is sometimes referred to as the kill chain, but this whole notion of perception, decision, action, that could be compressed down to zero with AI-based systems, integration, data integration, automatic targeting, and also kinetic control. So you would be in an environment where things would be happening faster than a human could respond. And then we projected that out and we said, what does hyperwar look like? What does it mean for teeth to tail ratios in militaries? What does it mean for the Western training advantage on manned platforms? Today, our fighter pilots are the best because they fly the best machines and they get the most training, 250, 225 hours a year. And so what happens when with autonomy, an opponent does not require 220 hours to best a pilot that has put in that kind of effort in flying planes? That literally is an entire book, and it's a huge body of work and something that we've been pursuing, but that came from this team and this group. With Boeing, then, we established SkyGrid. The idea there was, clearly the future is not thousands of manned aircraft in the sky. The future is millions of aircraft in the sky that are autonomously working at, and these are things that you might not even conventionally call aircraft, but will do things in our society economically, militarily, logistically, that will change the world. So we partnered with Boeing, the largest aviation company in the world, to make that happen. And that's really what the genesis of SkyGrid is. Then my friend Michael Brasseur, who's sitting here and is a real pioneer, the commander of Task Force 59, and Michael Stewart with him, his partner. They established the Navy's first autonomy operation through Task Force 59. And when they did that, we partnered with them to create this idea of the digital ocean working with NATO, and then also deployed these capabilities and demonstrated real firsts at IMX, a true real exercise. And then, of course, all the work that Logan and David and the SGS team are doing on the JADC2, in particularly reimagining this with AI sensors. So my point here is that for all that criticism over the last 10, 12 years, you're not even as good as a vibration analyst. Your AI will never be able to solve a domain-focused problem. You will never be able to achieve autonomy. Nobody will let you. We've just gone on and done it. And one of the spirits of Time Machine, one of the things that I really want our friends to take away from Time Machine is damn the torpedoes. If you want to build the future, every large organization will somehow, deliberately or otherwise, put some kind of a obstruction, in front of you. People don't generally like change, but the change makers have to bring about that change. And so no matter how hard and no matter how small we were when we started, these are factual things that we've done. We've deployed now on hundreds of thousands of cameras in 16 countries. We have 130,000 people using SkyGrid software. We have gigawatts of energy under management. Over the last 3 years, our AI software has shipped about 2 to 3 billion barrels of oil. We are making a small difference towards that vision. So when you leave here, my other dream and desire is you all leave here as friends, because you are brilliant people, extremely accomplished people with great connectivity with amazing organizations. And imagine just discussing, talking, getting to know each other, and then figuring out what we might all as a group be able to do together. There's going to be hopefully a lot of collaboration that comes out of this. The other thing that I want to talk about is something that I probably wouldn't have had the guts to put up here 2 years ago. Ray Kurzweil, a lot of people have read him, and many people have over many, many years now talked about why Ray Kurzweil is right over on the extreme end, and what he basically says is that, look, Moore's law is going exponential, and at a certain point, and here I think on this graph it's somewhere in the 2040s, 2045, computing power will surpass the cognitive capacity of every human being on Earth. This year, Computers have surpassed the cognitive capacity of a human being measured in a very specific way. Because again, that's been the criticism for Kurzweil, which is, well, hey, listen, you're talking about building bigger and bigger computers, but there's no obvious algorithm, there's no obvious software to run on these big computers to get to human level capability. That's been the big criticism. He isn't wrong about Moore's law, but sometimes you get lucky. And with the advent of generative AI and LLMs, I think Kurzweil just got lucky. Because what's happening is that with generative AI and with LLMs in particular, we are, even academics, and you have some of the best machine learning people here in the audience today. My friend, Professor Alex DeMarcus, Luis Sentis, Professor Bruce Porter, talk to them, ask them what they think about this emergent behavior that's showing up in these networks. So now we have algorithms that are at least at the broad level giving us evidence that we can run software on this hardware that gets us emergent, really amazing capabilities that are unexpected to us. I don't know whether the dates are exactly aligned, but I'll tell you something. I've never taken this chart as seriously as I do today. And that has changed in the last year, post-Transformers. This is not just my opinion. If you look at the current state of AI research, there are now papers being published on sparks of AGI showing up on these large systems with transformers, with GPT-level models. And GPT, just think of it as a placeholder for models of that type. Okay, there are several models of that type. Think of it as a placeholder. So you've got serious people now writing and examining the ways in which emergent behavior is showing up in these things. It's a time to take this seriously. This is no longer someone's pipe dream. There is measurable behavior that needs to be studied. And if this is true, we have finally discovered intelligent life on Earth that's not us. So now let me come to what people are saying now. Because you know, this whole idea of resistance, that's really what I want to get to. You believe in artificial intelligence. You see use cases to make the world better through the employment of artificial intelligence. You might even consider those use cases to be cost effective, to be powerful, to be speedy, and you really think you can make a difference in your organization, for your country, for your service, whatever institution you serve. So now what happens is that people have adjusted the skepticism a little bit. The first is, look, this whole AI thing, you know, it ran on fast computers and fast GPUs, right? You've had the benefit of that for many years, and of course, Moore's law is not going to hold. I mean, everybody's telling me that computers are already as fast as they're going to get. It's going to be really tough. The other is, oh, you know, we're running out of data. You know, I heard Sam Altman talk the other day, and he was saying like, well, I don't know that GPT-5 just by being a bigger model will be bigger. I don't know that large models will continue to scale. Like, where else will we get the data from? I was told GPT-4 is already all the internet. So now we've trained something on all the internet. Like, what's left to do? Okay. So let's examine these things, because again, what I'm trying to do is not an academic level takedown of these issues. What I'm trying to do is a practical way of evaluating the criticisms that you will get from others, from peers, from your organizations, so that you can address these criticisms and make progress. The most important thing is to make progress. And so if some of that can come across and we can equip ourselves with the tools that are necessary to make progress, then hallelujah, you know, that's what we want. So first of all, Moore's law won't hold. Okay, not true. If you look at the recent discussion that Pat Gelsinger, who's currently the CEO of Intel, just did, they have committed through a specific set of technologies, for example, gate-all-around. They've already now starting to migrate off of FinFET technology. They will be able to drive Moore's law with conventional techniques in the semiconductor industry for another 10 years. Number two, the way that we have these von Neumann architectures where memory and compute, ALUs, CPUs are all across a bus, and the way that they're all built, this is not the only way to do things. And in fact, to run AI algorithms to run backpropagation, to run some of the optimization type work, there are many alternate architectures that are being built now. So for example, neuromorphic computing, where chips take the shape of a brain. MEM computing, where memory and small processes are combined in memory cells. So the compute and the storage is in one place and doesn't have to traverse a bus. So some highly parallelizable operations can be done in this way much, much faster than in a conventional architecture. Then quantum computing. Now, probably the world's #1 quantum computing researcher, we're very, very lucky that he is in Austin, Scott Aronson, Professor Scott Aronson. And we just were at a talk that he gave at UT Austin a few days ago, in which he again explained that there are probably now growing linkages between quantum and machine learning, but it's not quite clear yet whether quantum systems will run machine learning algorithms the way we expect them to. But that could happen. So it could happen, hasn't happened yet. The other architectures, I would say, are probably more advanced. And then finally, just simple stuff like ASICs, application-specific ICs, and software optimizations. So when you look at Microsoft or Google developing TPUs, that's what they are. They're ASICs. They're a step beyond the GPU to run these algorithms really fast. So look, Moore's law won't hold. I don't think that's really a big criticism, because as long as it holds till 2045, which, if you remember from that earlier graph, is when compute outpaces all the brains in the world, I think that's probably good enough. The other thing I'll tell you is there's a criticism around large models won't scale. Oh, maybe this is true. Maybe it's true that large text-based models won't scale. But what we have discovered with transformers is token prediction. A word is a token. We've trained these big models on text, and we are interpreting the token as a piece of text. But actions are tokens. Images are tokens. Sensor returns, parts of images are tokens. So when you start thinking about what does a chat GPT-like system appear to be in the realm of action, is it the kind of thing that you can basically just show that system a small snippet of an action, and it will then be able to complete the whole action with expert proficiency, which means that we can embody that system in a robot, and that becomes the robot's nervous system and muscle control system? What about with imagery? What about with networks of these models, as Marvin Minsky used to say, society of mind, connecting many of these networks together. So my point is, when somebody says, oh, I don't know whether a bigger network will, there's so much more to explore. Multimodal networks, networks of models, society of mind, shared labor between even similar classes of models, that this is hardly a criticism. The last thing is that, why is GPT-4, GPT-3 so surprising? It's because we continued to scale and we weren't seeing amazing results. And then at some point, just magically, the results went through the roof. Many people who've actually practically implemented machine learning see this. It didn't happen with 10,000 rows. It didn't happen with 100,000 rows. Suddenly, at 9.3 million rows, the network just learned. The loss function was exactly where you wanted it to be. So my point is, it doesn't scale until it scales. There's no proof that says that there isn't another quantum of improvement coming down the road with a level of scale that we have not yet achieved and seen. And then finally, on data. Again, we're running out of data. Really, are we running out of data? We might be running out of data on Wikipedia. We might be running out of posts on Reddit, but that's not all data. All data is the sensorized world. There are sensors everywhere. Every Tesla car has 8 cameras. Where is all that data going? Every street now has sensors. There's planes and satellites flying over you all the time. There's drones in the sky everywhere. There's SDR, software-defined radios, that are picking up emissions that you don't even know exist. Oh no, we are not running out of data. And we have not built the models that can understand and process and make use of and drive value through this data. Similarly, we have not yet experimented with virtual systems that can create data. In virtual environments, what is generative AI? A type of AI that can create, that can generate. And often, the reason why it's impressive is because it's quite different to what was put in. It can be quite different. So whether it's physics-based simulations, digital twins, there's a whole cornucopia of opportunities to generate more data. We are not running out of data. Think about this in simplistic buckets. One, in my view, the theme is the AI of atoms and bits. How do you take AI and how do you combine atoms and bits to drive change? How do you examine the quantum of change when you put atoms and bits together? Well, clearly, in the area of battle, what you're dealing with is zero lapse. I talk about collapsing the OODA loop. I say that that is one of the characteristics of hyperwar, but really, if you will, the basic principle is zero lapse. Zero lapse of what? You take the word on the left, you take the word on the right, and you put zero lapse in the middle. Anything that matters to you in your doctrine, in your execution, and you ask the question, if this were zero lapse, what would happen? And I tell you what, most of the things that you think can be zero lapse are probably already being worked on to make them zero lapse. And if not by us, by someone else. Extreme automation and autonomy. At our first or second Time Machine conference, we had a wonderful Austin-based company called Apptronic show us their humanoid robot. The year prior, the Spark Cognition Lab had a humanoid robot prototype called Alexander that we showcased. And so we've been fascinated for the last decade with this idea of embodiment, taking powerful neural models and sticking them into humanoid robots because then they can navigate the world the way it was designed for human beings to navigate. Apptronic has made tremendous progress. And humanoid companies are coming out now, not just the dancing robot kind, but the kind that actually does real jobs in a warehouse, that can actually lift things and it can do things which otherwise a human being would be doing. So that's another area which is, it's not going to happen, it is happening. And then finally, this idea of our Spark Cognition mission of software-defined infrastructure. Look, I'll tell you one small thing, just given the nature of the audience. The engagement model that China has with, let's say, developing countries, they'll say, okay, listen, we want to work with you, and here's how we can work with you. We have 5G that we can help you develop. We have companies like ZTE and Huawei, we can do that. We also bring in a lot of capital capability, so we'll build roads for you, we'll build power for you, we'll build dams for you, we'll build a port for you, we'll also deal with your security issues, so we'll provide you with security gear. That is called holistic engagement. Forget for a moment what the color of the flag is. Now just imagine yourself in the shoes of a nation that's receiving that message. When they receive that message, they look at it as benefits all around. Holistic engagement, financing, all of these things coming in. If we cannot do that because of funds, because of bureaucracy, whatever the reasons are, one thing that we can do is we can package American innovation as artificial intelligence that sits on top of existing global infrastructure and supercharges it. So a partnership, for example, that is extremely viable between America and many developing countries is a partnership based on the fabric of artificial intelligence, which brings benefits beyond just the military. It brings social benefits, benefits in power production, benefits in safety, and so on and so forth. So this is a really, really important idea, software-defined physical infrastructure. This is not the guy to be. You don't want to be the person who does the right thing so long that it becomes the wrong thing. One has to be open to change. And I think this is kind of the essence of this message, which is that when the world changes, you have new facts. You believed a certain thing, the world has changed, adapt to those facts. And how can we adapt to those facts? So in our organization, for example, generative AI is working. You can absolutely apply generative AI to automate processes. You can use it to accelerate computation. Spark Cognition has accelerated computation for one of the largest energy companies in the world by a factor of about 100. Completely changed the way fundamental things are happening inside the largest companies. Amplify sensors, be able to find meaning and reason. Michael will remember that one of the deployments around AI with IMX was around augmenting sensors that individually couldn't find whatever needed to be found, but with AI they could. And so that's a huge use case. And then extend your data. If you have sensors in your environment, are you capturing everything? Are you capturing derivative data? Are you running simulations to create data? Do you have a model around digital twins? Embed cognition at the edge. Make individual things smart. What we're doing with cameras. We're putting this at the edge, not in the cloud. Every individual asset has some level of intelligence. Models for machines. Develop models not just for a keyboard typing in and a monitor giving you a response, but models for machines that are relevant for the operation of that machine. This is an area, again, very little effort is being invested here, but there's tons and tons of potential. And then finally, productize models. You have in your organizations data and the ability to build models that are revenue streams for you. They're partnership streams for you. So if you really look at AI and you really look at embracing AI, there's a large art of the possible, truly. And really, that is the message that I wanted to get across today. Again, just to repeat, this is a fascinating, marvelous, amazingly experienced group of people here. And if all that comes out of this is friendships, all that comes out of this is the sharing of experiences, and you end up doing something together with us, amongst yourselves, with other colleagues you found here, this will be an absolute victory in my mind. So thank you very much, and I hope you have a wonderful conference.